So the first formula we have is we need to be able to find the slope of a line. So the slope basically tells us how steep a line is. Okay, so like if we look at this line, how much does it increase for every 1 unit across we go in terms of the x direction? So that's the way we can think about it. So if we look at this line here, the way we think about slope is for every 1 unit I go across in terms of the x, so going from -1 to 0, how far up am I going? So when I run 1 unit, what am I going up? What am I rising? And our slope of a line is the rise over the run. Okay, so that is what it is. If we have a line that is going up from left to right, it is going to have a positive slope. If it is going down from left to right, it is going to be negative. The slope is going to be a minus. And then based upon how steep it is, that will tell you the slope of the line. For example, if I wanted to draw a line with slope 2, starting from here, I go across 1 and then up 2. So this would be a line with the slope of 2. And then again, across 1, up 2. That line will have a slope of 2, which we can see is pretty vertical. Whereas if I drew a line that had a slope of a half, so that means when I go up across 1, I go up a half. When I go across 1, I go up a half. Across 1, up a half. We can see that that line is a lot less steep than the one with the slope of 2. So the slope of 2 is that line. The slope of a half is that line. Okay, but they're still both going from, they're still increasing from left to right. Whereas if it was a minus, it would be going down. Now, to find the slope of any line, we have a formula in our log tables. M is equal to y2 minus y1 over x2 minus x1. So this is in our log tables. The first formula here, m is equal to y2 minus y1 over x2 minus x1. So if we want to work out the slope of a line, the first thing we do is write out the formula. M is equal to y2 minus y1 over x2 minus x1. Now, to get the slope of a line, all we need is any 2 points on that line. So any point on this line. Now we're trying to get the slope of the line L. So that is this line here that they've drawn in black. So we need 2 points on this line. Can anyone spot one that's like distinct? Because for example, what I mean by distinct is we can see that this right here is a point on the line. But can we be very accurate with what that coordinate is? Not really. We know it's roughly, minus 0.5, and let's say like the y is like 2.4 maybe, but we don't have a precise point there. Is there any place on this line that we can be very precise with the coordinates? So just 1 point. So on this line L, is there any distinct points? The shop, exactly. So both of these headed, the shop, minus 3, 1. So that's going to be one of our points, the shop, which I'll write down here. So we take minus 3, 1. That is a point on that line, as we can see, because the line goes through it. And what's the other one that is pretty distinct as well? 4 and 5, exactly, the school. Yeah, so we're exactly 4 across, we're exactly 5 up. There's no guessing there. So we take any 2 points on the line. Notice both of those points are on the line. And once we take these 2 points, we just, and this is what we always do with coordinate geometry, we call one of the points x1, y1, and we call the other point x2, y2. It does not matter which point you call x1, y1, you'll always get the same answer. So it doesn't matter. And then what we do is we just sub it into this formula. So therefore our slope, m, is going to be y2. y2 is 5 minus y1, y1 is 1, all over x2, x2 is 4, minus x1. And be careful with this now, there is a minus in the formula, but x1 itself is minus 3, so we're doing minus 3. So then we can put this in our calculator if we want, but on the top we're going to get 5 minus 1, which is 4. And what am I going to get on bottom? 4 minus 3. What's a minus by a minus? A plus, exactly. So we're going to get 4 plus 3, which is equal to 7. So the slope of that line L, give your answer as a fraction, so we'll just leave it as that, is 4 over 7. So intuitively, what does that mean about this line L? So we can approximate 4 over 7 just to like see what it is. If we do 4 over 7 in our calculator and change it to decimal, it's roughly 0.57, okay? So it's roughly 0.57. So we know that the slope, what that means is every time I go across 1 in terms of the x, I am going to be going up 0.57 of a unit. So when I went from -3 to -2, so one change, or 1 unit in the x direction, I went from being vertically up 1 to 1.57 roughly. That's how it works. So we have a slope of 4 over 7. Okay, so to find the slope of a line, we have a formula in our log tables, and all we need is any 2 points on the line. It can be any single one of them. Now, in this one in particular, we can't really, guess like this point, what are the coordinates of this point. So we try to take ones that are like, we can be absolutely sure are right. Like this is -3, 1, this is 4, 5. Okay, so once we have any 2 points on the line, we just write them down, write down the coordinates, and that's why we start on that, because it's the most important thing. We need to be able to write out the coordinates. So write out the coordinates of the shop, -3 and 1, okay? And then we have the school, which is 4 across and 5 up, so it's a 0.45. We then call one of the points x1, y1, call the other one x2, y2, and we just sub in everything into the slope formula, which is in our log tables. So we did y2 is 5, minus y1, minus y1 is 1, so 5 minus 1 on top. And then on bottom, x2 is 4, minus x1, and x1 is -3. So there is a minus in the formula, and we have to be careful about this. So there is a minus in the formula, but then x1 itself is -3. So we're doing 4 minus -3, so it becomes 4 plus 3. So that's how we get 7 in the bottom. And then 5 minus 1 on top becomes 4 over 7. So that is how we get the slope of the line.